Example 2, this is another type of ratio problem that doesn't use the word ratio. All right? But it's telling us how to make this compound. We're making some chemical compound. And we're mixing sulfur with other materials to make the compound. All right? And the problems are going to be worded similar to this when it's a compound problem, or like a science problem, a chemical compound. You're going to be mixing some chemical with some other chemical, or in this case sulfur with other materials, all right, in order to make some compound. The compound is the total. The things going in to make the compound are the parts. So it's the same family of problems, it's just worded a little differently. We're still dealing with a ratio of ingredients. All right, the ingredients of this compound, we're going to put compound at the bottom because that's our end result of our experiment. We're making some compound. We're mixing sulfur with other materials. All right? So the initial statement here is going to help us get the ratio of ingredients correct. And then we need to make the new compound a different amount of the new compound, so we have to adjust our recipe. It'd be similar to if you're baking and you have a cake recipe and you want to make one cake. All right, and the ingredients are, let's say, 2 eggs, maybe a cup of flour, half a cup of flour, I don't know, I've never baked cakes. A cup of sugar, let's put a lot of sugar in our cake. Probably some milk, I don't know, and stir it all up, right? Anyway, but then you want to make 2 cakes, you double everything, right? The ingredients, so 4 eggs, a half cup of flour, 2 cups of sugar, a cup of milk, whatever. I'm probably going to make some like syrup or something, I don't know. Anyway.
It doesn't turn out like
The point is, if you have some recipe that makes a certain amount, let's say it feeds 8 and you want to feed 24, you got to triple everything, right? So you triple the ingredients. That's all that's happening here. We have the ingredient list to make exactly 3,000 kilograms of the compound.
That's the ratio, not the actual.
That's the ratio. It says it takes 600 kilograms of sulfur to make 3,000 kilograms of the compound. So the initial creation of this compound is we're making 3,000. It takes 600 kilograms of sulfur, and that means it takes 2,400 kilograms of other materials. Again, this and this have to make that. So the 2 parts have to make the whole. All right? So I have a ratio of ingredients here that makes exactly this much compound. So again, the bottom row represents the end result of my experiment. The top 2 rows represents what I'm putting into the bowl to mix together to make the compound. All right, this recipe, and I looked it up in my book, it says, well, 600 kilograms of sulfur, done. 2,400 kilograms of other materials, done. All right, but then, wait, I need 4,000 kilograms. This recipe is only for 3,000. How in the world am I going to make this? So I want to make 4,000 kilograms, so I'm going to make 4,000 kilograms. How many kilograms of other materials would be needed? So our actual numbers are here. So they're asking me for that. Now here, looking at scale factor, the scale factor this time is 4/3. Maybe we don't want to do 4/3. Maybe that fraction worries us a little bit. So sometimes scale factor is not as efficient as proportion. So if I make the proportion 2,400 over 3,000 equals x over 4,000. You are allowed to reduce before you cross multiply. You can reduce horizontally, you can reduce vertically. I'm going to reduce horizontally because it's really easy. Divide both these numbers by 1,000, you get 3 and 4. And that's good enough. 3 and 4 are small enough I can work with. So 3 times x is 3x. And 4 times 2,400 is 9,600. We divide both sides by 3. That leaves me with x equals 3,200 kilograms of other materials. How much of sulfur will we need?
Too much.
800 kilograms. All right? So, again, chemical mixture problem, or it's actually a chemical compound problem here, it's just a ratio problem. And treated as such, the initial setup gives you the ratio numbers, and then what you're trying to create, how much of whatever do you need to make that happen is going to be asked.